Welcome. This is 9.2 task. It's called chocolate versus vanilla. And you're looking at some different probabilities based on a set of data here. And the idea is which flavor, is it chocolate or vanilla? And then the data is broken by gender. They're assuming a binary gender, which is a bit outdated, but that's the data that they have. So they give you some information to start. Oops, that's not what I wanted. There we go. Okay, they give you some numbers, females, males, so you've got the total. They gave you a percent of, put this over here, a percent of vanilla for males. So you can calculate that total number of males. It's 3588, and from that you can make some other calculations. As they also gave you chocolate for females, so from that we can make some calculations. So by subtracting and adding, we can come up with some other numbers. Here's what we had: 4024 and 7612 and 2422, as well as 7154. So this is the numbers that we're going to use for our analysis here. And you can see some different ways that they've represented this data, same data, but you can also do it in a Venn diagram. You can also do it in that tree diagram like we worked with before. I'm going to actually start with the tree diagram. So the probability of female, assuming binary gender, is the number of female divided by the total. And I can see the number of female here is 8756. And the total is 14766. So from this, I'm able to calculate the probability of female as well as the probability of male. And let me look, I had done that earlier. Okay. So for that, I would convert that into a decimal. I could also do probability of male here. This would be 6010 divided by the total, which is 14766. So that'll give me the probability of each. Now, it also says, given that you're only looking at females, what is the probability of chocolate as a preference? And so this one is conditional probability. Conditional, okay? And in this case, the condition is female. And the question is, given female, what's the probability it's chocolate? So you're only looking at that female of 8756. And out of the 8756, the chocolate was 4732. So that is the probability, the conditional probability of chocolate, given that you're only looking at female. And then the other part of it is, what is the probability of chocolate and female? So to do that, again, we're looking at the total number, 14766. And we're looking at how many are both chocolate and female, and that would be 4732. And so from this, we have a probability of both. Similarly, on the other side, you can also say, what is the probability of vanilla given male? So the males are 6010, and given male, what is the probability of vanilla? Well, how many vanilla do we have? And if we look here, we see 3588 of those males had a preference for vanilla. So my probability would be 3588 divided by 6010. That's different than what's the probability of getting both. So this would be out of the total, which is the 14,766, and the probability of both, looking at that, would be the 3588 out of the 14,766. So you can see these are two different things. Probability of vanilla given male, you're only looking at the male population, so it's 3588 out of that, or the probability that you have both conditions and you're looking at the total population, and then you're looking at 35, I guess that's an 8, 3588 out of 1476. Okay, some other things that we can get from this would be right here, how many are both, say, chocolate and female. We can get that from our chart, and we can see chocolate and female is 4732. Okay, and then we can also see how many are chocolate but not female. So here's our chocolate, 4732 are female, 2422 are not. So then we've got our 2422. And then if we added up all three of these numbers and subtract it from the total, we could see how much was on the outside. In other words, neither female and also not chocolate. And we could also do that calculation. So the ones that aren't female and the ones that aren't chocolate would be vanilla, and it's the vanilla males, which is 3588. So there's another piece of information that you can get. So really you can fill all three of these out if you just have one. And probably the easiest to start with is that table. Some things to look at. I looked at what information is hidden for each of these. In other words, what do you not know just by looking at the diagram? For the tree, you don't really know all the totals. You have the individuals for each of these conditions, but you don't know the totals. For the 2A table, you don't know what probabilities are. You just have the raw numbers here. And then for the Venn diagram, you have two separate conditions. One is the female as opposed to male, and chocolate as opposed to vanilla. So you don't really know the total very easily. You have to calculate that.